I'd like to go over some examples of how to find a percentage based on a picture where you don't have equal slices, such as these two here. So what I'm going to do is I have them drawn over here. And so looking at this square here, we have it divided into 4 pieces, but then we have this fourth over here divided into other sizes. What we need to do is we need to divide all of our pieces into the same little bitty pieces as we do here. You always want to find your smallest piece and divide your entire thing by that smallest piece. So what I'm going to do first is I'm going to take each of my triangles and I'm going to divide them into 2 so that I have this piece here, and then I'm going to divide each of those triangles into 2 so that I have all equal pieces. Once I have all equal pieces, I can count up the number of pieces that I have. And so I can go through there. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I totally forgot to divide that last one. So I had 12, 13, 14, 15, 16. So I should have 16 pieces total, and that's going to go on our denominator. And I've got 1 on the numerator. And so whenever I take 1 divided by 16, I get a 0.0625. And then to get that to be a percentage, there's one of 2 ways. I can either move the decimal place 2 places to the right, or I can take that 0.0625 and I can multiply that by a 100, and I should get a 6.25%. So when you start with something that looks like this, and you can see, okay, I've got this big piece here, but I've only got this small piece that is shaded. You need to divide each of these larger pieces to be the same size. It's kind of like whenever you have a Hershey bar, you break it in half, but you know how it has the little bitty pieces that you can count up where it's all divided up. It's the same type of thing. Divide your larger pieces into those smaller pieces. Now I still want to look at this one. So we have this one large piece down here, but we also have this smaller piece here. This one's not as difficult to break up. All we're going to do is we're going to drop these lines down here. And so now we have 1, 2, 3, 4, 5, 6 pieces. And we have 1 piece shaded in. The reason why I want to look at this one is because whenever we divide 1 divided by 6 in our calculators, we get 0.166666666, and then you have a 7 at the end. Well, the 7 at the end does not mean that it actually stops. What this is that it means that we have a repeating value. And so if we were to take this and multiply this by 100, we would get that we have 16.6 repeating percentage. We don't really like using repeating decimals when we're looking at percentages. It's not a very accurate description. In the previous problem, this is a very accurate description. Think about it. Yes, you have exactly 25 cents. That makes sense to us. That 0.25 is an exact value. Whereas down here, a 0.6 repeating, that's an estimated value. That's a rounded value, okay? So what we can do, we've already discussed about ratios and things of that nature. We can actually do a ratio. Think about 1/6 is equal to our percentage that we're looking for, and all percentages are out of a whole of 100. Okay, so now what we're going to do is we're going to do a little bit of cross multiplying and solving our ratio. We're going to take 6 times x, and we're going to get 6x is equal to the 1 times 100, which is 100. I then will divide both sides by the number that is attached to the variable, which is the 6. This way, this cancels out. And again, I know that whenever you put it in the calculator, you're going to get that 16.66666. Let's go back to our long division. I know how much we love long division, though. So let's look at 100 divided by 6. Well, 6 can't go into 1, but 6 can go into 10. 6 goes into 10 one time. 1 times 6 is 6. We take the difference. There's a remainder of 4. We drop down our 0. 6 goes into 40 6 times. 6 times 6 is 36. We take their difference with a remainder of 4. So we have 16 whole with 4 out of 6 left over. This fraction is the same thing as this decimal, but this fraction is actually a more accurate description because we don't have anything repeated. Now, the only thing about this fraction is we need to simplify it. So we're going to divide both the numerator and the denominator by 2, and we get 16 and 2/3%. This is the most accurate description of our percentage. These two are similar. They're not exactly the same because, again, this is a rounded version. This is the exact version. So I hope this helps with finding the percentages of figures that do not start out to have the same size shapes. If you have questions, let me know.